All right, welcome back. We're on day 8 of our AI journey, and today we're diving into something you literally use all the time, maybe without even thinking about it. I'm talking about natural language processing, or NLP. You know, the magic that lets your phone actually understand you.
So have you ever stopped to think about it? You say, hey Siri, what's the weather like? And boom, it just works. But how? How on earth does a machine, a hunk of silicon and code, understand our messy, complicated human language? Well, that's the puzzle, right? And that's exactly the puzzle NLP is built to solve.
Okay, so to really get how amazing the solution is, we first have to talk about just how massive the problem is. And let me tell you, for a computer, our language is, well, it's a total nightmare.
Just take a look at these. Our brains just figure this stuff out in a split second, right? Like, I saw her duck. Does that mean I saw her move down? Or I saw a bird she owns? We get it from context. Or sarcasm. When someone says, oh great, another Monday, we know they're not thrilled. But a computer, it just sees the word great. And what about the word apple? Is it a fruit? Is it a multi-trillion-dollar company? For a machine that thinks in ones and zeros, this is like navigating a minefield.
So yeah, when you really stop and think about it, teaching this wild, chaotic system to a machine, it's not just another little problem to solve. It's truly one of the greatest achievements in all of artificial intelligence, period. So how in the world did we pull it off? How do we crack this code? Well, it wasn't some single aha moment. It was more like building an assembly line for language, and we call it the NLP pipeline. So this pipeline takes in all that messy human text and gets it ready for the machine to digest. First up is tokenization. It's basically just chopping up a sentence into its individual words or pieces, its tokens. Next is pre-processing. This is the cleanup crew. It makes everything lowercase, gets rid of punctuation, standardizes it. But the final step, this is the real magic. We have to convert those words into numbers. Because let's be real, computers don't speak English, they speak math. And the huge breakthrough in turning words into numbers was a technique called word embeddings. This is so cool. Instead of just giving each word a random ID number, we give it a whole set of coordinates, a vector. You can think of it like placing every single word on a giant multidimensional map of meaning. And the word's location, its vector, isn't just about what the word is, but how it relates to every other word around it. And this right here is the classic example that just blows your mind. It shows the real power of this. You can actually do math on meaning. If you take the coordinates for king, subtract the coordinates for man, and then add the coordinates for woman, what do you get? You get something incredibly close to the coordinates for queen. It's incredible. For the first time, machines weren't just seeing letters. They were starting to understand relationships and concepts. This was an absolute game changer.
Okay, that's the theory. But where do you actually see this stuff in the real world? Well, the answer is everywhere. This isn't science fiction anymore. It's literally in your pocket right now.
Think about it. Every single time you type something into Google, NLP is working behind the scenes to understand your intent. When you talk to Siri or Alexa, that's a whole lot of NLP. Google Translate, juggling all those languages? Yep, NLP. It's the engine that powers sentiment analysis, when a company wants to know if reviews are positive or negative. And of course, it's the absolute core of tools like ChatGPT and Claude. And to give you a sense of the scale here, just wow, let's go back to Google. Every single day, NLP is at the heart of processing over 8.5 billion searches. That's just a staggering amount of human language being interpreted by machines every single second of every single day.
Okay, so the NLP pipeline and word embeddings were fantastic, a huge leap forward. But then, around 2017, something happened. A new architecture dropped that didn't just make things a little better. No, it completely changed the game. It was called the transformer.
So before the transformer, models had to read text one word at a time. It was slow. And if the sentence was really long, they'd kind of forget what was said at the beginning by the time they got to the end. But transformers, they're totally different. They look at the entire sentence all at once. The secret sauce is this mechanism called self-attention. It's brilliant. As the model looks at each word, attention lets it weigh the importance of all the other words in the sentence to understand the context of that one word. It connects it back to the noun it's referring to, for example. It's what lets the model finally see the whole picture.
And this transformer revolution is what gave us the big names we all hear about today. We've got models like Google's BERT, which is an absolute genius at understanding text. It's a huge part of what makes Google search so good. Then you've got OpenAI's GPT family, which are masters of generating text. Yep, that's what's under the hood of ChatGPT. And then you have other cool models like T5 that are designed to be super flexible.
So what is something like ChatGPT really doing under all that complexity? What's its fundamental job? Well, at its very core, it's a next token predictor. It has read a mind-boggling amount of text from the internet, and from that, it has learned patterns. Its entire job is to look at a sequence of words and predict, based on probability, what the next most likely word should be. You can really think of it as the most powerful, most sophisticated autocomplete system ever built.
All right, let's do a quick recap of what we've covered. We started by looking at just how hard language is for a machine. Then we saw how the NLP pipeline tamed that chaos, turning words into numbers that computers can actually work with. We saw the breakthrough of word embeddings, which gave those numbers real, conceptual meaning. And finally, we saw how the transformer architecture and its attention mechanism completely revolutionized the field, leading us right to the incredible tools like ChatGPT that we have today.
And that leaves us with a really deep question to chew on. This whole system, this massive scale pattern recognition, it works astoundingly well. It feels like it understands us. But if all it's really doing is predicting the next most likely word, is that the same as understanding? Does it know what it's saying, or is it just an incredibly convincing mimic? That right there is one of the biggest, most fascinating questions in the entire field of AI right now.